around the beginning of the 19th century that a famous German chemist attempted classification of the then known elements. It was none other than Johann Wolfgang Dobereiner who did so. He classified the elements known at that time in a particular manner. He placed them into groups having 3 elements each. Do you think these groups of 3 will have elements arranged randomly? Of course not. What's the unique way of placing these elements then? It's simple. Dobereiner arranged the set of 3 elements in such a way that the average of atomic mass of first and third element in the set gave him the atomic mass of the middle element. In simple words, the atomic mass of the second element will be approximately equal to the average of atomic masses of the first and the third element. Let's take an example to understand this better. One of the triads he suggested was that consisting of lithium, sodium and potassium. The atomic mass of lithium is 6.9, while that of potassium is 39. So if you take their average, what would you get? Yes, you get 23, and 23 is the atomic mass of sodium. And this is exactly what Dobreiner had in mind when he framed the triads. However, this is not a perfect method of classification because not all elements follow this principle when arranged in triads. Also, when Dobreiner had put forth the system, only a few elements were known to him. With the discovery of newer elements, this system of grouping elements didn't really work. After grouping the elements in a series of 3, there came a system in which the elements were grouped in series of 8. Yes, this system was put forth by an English scientist named John Newland in the year 1866. There were around 56 elements that Newland could group. He simply arranged the elements in an increasing order of their atomic masses. At the end, he realized that these could be grouped such that every 8th element resembled the first. Astonishingly, the arrangement also stuck an analogy in his mind. Well, can you guess what analogy popped in Newland's mind? Let me help you with that. These are like octaves. Yes, octaves found in music. In case of octaves, we find that every 8th note is same as that of the first one. He found that every 8th element in the series resembles the first in various ways. This is how Newland arranged the elements in a table. For instance, as we can see here, if we consider lithium, then the 8th element after it would be sodium. You would be amazed to know that they both share similar properties. Next immediate examples would be that of beryllium and magnesium. Even these are at positions such that magnesium is 8 places away from beryllium. And yes, they both do resemble each other. With this analogy, Newland named the grouping system of elements as laws of octaves and even Newland's laws of octaves. Although the arrangement pattern was quite good, but it was valid only until calcium and not applicable for elements after that. After calcium, every 8th element did not have properties similar to that of the first. By that time, there were only 56 elements known. Newland assumed that more elements will not be discovered in the future. Many elements were of course discovered later, but did not have properties that could fit in the system in any possible way. Another notable drawback in this system was that cobalt and nickel were placed in the same position. And this position was in the group of halogens like fluorine, chlorine and bromine. But these halogens have completely different properties as compared to cobalt and nickel. With all these limitations, Newland's octaves also had to be ruled out. Later, there came a proper, well-defined system which was put forward by a famous Russian chemist called Mendeleev. He not only gave a systematic approach to classify elements, but even laid the foundations of modern periodic classification that is widely used today. Let's have a detailed look at the periodic classification of elements as presented by Mendeleev in the next video.